Hello everyone, this is Jared Kamen, Associate Professor of Engineering Technology at Lone Star College, and I am here explaining a basic statics problem in which we are to determine the magnitude and the direction of the resultant force of all of these forces on this particular eye hook. Okay, and so the first thing that we are going to do is we are going to draw our own free body diagram. And our free body diagram is going to include all of the forces, and so we have our force kind of going up this way, which is force 1, 800 newtons. We have a force kind of going up this way, which is force 2 of 600 newtons. And then we also have a force coming down this way, which is force 3 of 650 newtons. Alright, I am going to have a dotted line here that represents the horizontal, because we not only need to write the forces on our free body diagram, we need to write the directions too. And so I need to find all the angles with respect to the horizontal. So for force number 1, it gives us an angle of 60 degrees. For force number 2, we have an angle of 45 degrees with the horizontal. And so if this angle is 45 degrees with the horizontal, then the rest of the angle, having to be 90 degrees between the y and the x-axis, is going to have to be 45 degrees too. So force 2 is 45 degrees from the horizontal. We also have this force right here, which is given to us, the angle is given to us through a little triangle. Okay, and so I'm going to write that triangle down here, because we can use this triangle to determine what our angle is. And so we want to identify the angle with from the horizontal if we want to find our angle theta from the horizontal. Okay, and so that means we have a 5 right here, and then we have a 13 here, and then a 12 here. So we're trying to find out this angle theta with respect to the horizontal. Okay, and so what we can do is we can take the tangent of theta and set that equal to opposite, which is 5, over adjacent, which is 12. Then we take the tangent inverse on both sides, and we get the tangent inverse of 5 over 12 is what theta is. And we find out that theta is simply going to be 22.62 degrees. Now, there's another way I can do this, in which I can just go ahead and note the ratios for sine and theta, and so for sine and cosine rather. And so I know that the sine of theta, starting from the reference angle, is opposite over hypotenuse. So sine of theta equals 5 over 13. Okay. I also know that cosine of theta is adjacent over hypotenuse. So cosine of theta is 12 over 13. And so I'm going to hold on to these, because these will come into use when I'm going ahead and resolving all my slender forces into different components. Okay, and so now I have all the angles for each one of my forces. Now it's time to resolve these forces into rectangular components. Okay, that means that each force is going to have a x component and a y component. So for force number 1, there's going to be an x component here and a y component here. Force number 2, there's going to be an x component here and a y component here. And I might just go ahead and do this in red so you can see it better. But for force number 3, there's going to be an x component here and a y component here. Okay, and I think I will go ahead and do that in red so that you can differentiate between the two. So here's your components here. Hopefully that will help a little bit. Alright, so now we have to find out the values of these components. And so what we're going to do is, we know that, for example, for force number 1, if we're looking at the opposite from our reference angle, then this component in the y direction is just going to be the magnitude, which is 800 newtons, times the sine, since the opposite side of our reference angle, which is 60 degrees. Okay, if we want to identify our x component for force number 1. We take the magnitude again, which is 800 newtons, and then we multiply by the cosine, because it's the adjacent side to the reference angle. So multiply by the cosine of our reference angle again, which is 60 degrees. Let's go over to force number 2. Our y component for force number 2 is just going to be the magnitude, 600 newtons, times the sine, again, because that's the opposite side of the reference angle, of 45 degrees. And then our x component is going to be, start out with the magnitude again, 600 newtons, times the cosine of 45 degrees. Now, let's go ahead and identify our components for force number 3. So what we can do is do the same thing that we've been doing before. Start out with a magnitude, which is 650 newtons. We'll do that for the y component here. And so we have 650 newtons, okay? And what we could do is just multiply by the sine, which is the opposite of 22.62 degrees. Now, another way we could do it is by understanding that we already know what the sine of theta is. Okay, from our ratio, sine of theta is just going to be 5 over 13. And so instead of doing sine of the angle 22.62, I can write down just 5 over 13, which represents sine of theta. So that's what I'm going to do. So we multiply by 5 over 13. I'm going to do something similar for our x component of the force number 3. So, and that's going to be, so we'll put it down here, 650. And instead of saying the cosine of our angle 22.62 degrees, I'm just going to realize that, hey, I already have the cosine of the angle right here. That's just 12 over 13. And multiply by 12 over 13. Okay? And so now we have all the values of each of the components for each of the forces. That's 6 forces in all. So what we want to do right now is we have to remember the formulas for the magnitude of the resultant and also the angle of the resultant. Okay, and so the magnitude of your resultant is just going to be equal to the root sum of squares of your x and y components. In other words, I'm going to take the square root of the x component squared plus the y component squared. My angle is going to equal to the inverse tangent of the y component divided by the x component. Okay, so really all you have to do is obtain the x and y components of the resultant, and then you can find the magnitude and its angle. So remember that the resultant is just the sum of the forces of all the forces. So that means that if I want to get the y component of the resultant, that's just going to equal the sum of the forces in the y direction. So let's go ahead and let's add up all those forces in the y direction. Well, we have this force, the y component of F2, which is 600 sine of 45. We also have this force, which is the y component of force number 1, which is 800 times the sine of 60. Now I'm adding these two forces because my convention is that in the y direction going up is positive. So that's why I'm adding these two forces. If we look at force number 3 over here, we see that it's going down. And so I'm going to subtract 650 times 5/13. Okay? Then I'm going to add all of that up together, and that's going to equal my y component of the resultant. If I do add all of that up together, I can see that that's going to equal to 876.1 newtons. Okay, so I'm taking this out to 4 significant figures because my final answer is going to be to 3 significant figures, so I need to have something to round that to. Now, what are my the x component of the resultant, where going to the right is positive? I know that's going to equal the sum of the forces in the x direction. Okay, and so what do I have? I have 600 cosine of 45, but that is negative, so minus 600 cosine of 45, because it's going to the left, so I subtract that. I also have for force number 1 800 cosine of 60, that's going to the right, so add 800 cosine of 60. And then also force number 3, 650 times 12 over 13, so I add that because that's going to the right, 650 times 12 over 13. Okay, I add all those together and I get 575.7 newtons. So now I just take those values and I put them in here and in here to get my magnitude of the resultant and the angle. So we're going to go ahead and do that. So the magnitude of my resultant force is just going to equal the square root of the x component, which is 575.7 squared, plus the y component, which is 876.1 squared. Okay, and that comes out to be 1,048 newtons. I'll go ahead and round it to 3 significant digits, which is 1,050 newtons. Okay, now my angle is going to be the tan inverse of 876.1, because that's the y component, over 575.7, because that's the x component, and that equals 56.69 newtons. I round out to 3 significant figures, which is, I'm sorry, not newtons, that's going to be degrees, because it's an angle. I round that to 3 significant figures, that's 56.7 degrees. Thank you very much.